Hello, this is Mr. Joseph, and we're going to do some graphing and factoring today. So when we first look at this first equation, looking really nice, this is called standard form. So standard form is when it's not factored or have the parentheses. So when something is a standard form, I always advise students to look at two things pretty quickly, and I'll highlight them right here. I would look at, is it positive or negative? So you look at the leading coefficient, which is 8. So we know that is positive. And then I look at the highest power, and this is called your degree, and it's odd. So you need to know your basic functions in order to know behavior. So for instance, if I told you y equals x squared, everybody knows that this is a parabola and it's up and up. So I call this even and positive. So that means the behavior is going to be up and up, is what I call it. If I made it negative, it flips the graph down. So this is even and negative. I call it down, down. And I'll get to the fancy notation later. So a lot of people remember x squared. The one that we struggle with is what's a simple odd function. So a simple odd function could be x cubed. So if I plug in a negative number, so for instance, if I plug in -2, -2 to the power of 3 is -2 times -2 times -2, which is -8, which is here. If I plug in a +2, it's 8. So I remember that x cubed looks like this. And this is an example of something being odd and positive. And I call this down, up. And then if I just flip it, then the graph just looks like this. This is odd and negative. And I call this up, down. So when looking at this example, we highlighted that it's positive and odd. So I know that it's going to be down, comma, up. And I'll write that properly at the end when we actually do the graph. But just keep in mind that the ends are going to start down and it's going to end up. So keep that in mind. So now the next question is Y-intercept. So when I do the Y-intercept, I always like to tell people Y-intercept is when x equals 0. So what I'm going to do is I'm going to plug in 0 for every x that I see and calculate it. Then when I do this, I get 0. So that means my y-intercept is 0, 0, which kind of makes sense because if I plug in 0 to every x, it makes everything go away. So I got that. Next, for my x-intercept, this is when it gets tricky. You actually have to factor in order to find your x-intercept. So that's what we're going to do next. So let's take 8x cubed minus 6x squared minus 2x. And we're going to set this equal to 0. And the reason why we're setting it equal to 0 is because your y value is 0 when you're looking for your x-intercepts. And don't forget, x-intercept is the same thing as zeros, roots, or solutions. So when I look at a factoring problem, I always try to find the GCF. So 8, 6, and 2 are all divisible by 2, so I can take a 2 out. If I have 3 x's, 2 x's, and 1 x, I'm allowed to take 1 x because that is the most each term could give. And now I'm just doing 2x times what gives me 8x cubed. That is 4x squared. 2x times what gives you -6x squared. That's minus 3x. And 2x times what gives me -2x. That's minus 1. So I'm one step closer to finishing this problem. When I see 2x, everybody, this is linear. So that's done. There's no power, so I can't break that down anymore. But when I look at this right here, which is 4x squared minus 3x minus 1, I can still break this down even more. So when I'm factoring 4x squared minus 3x minus 1, I'm just going to show my work to the side. You got two options. You got 2x, 2x, or 4x and x. My product, or the number I'm trying to multiply to, everybody, is -1. And the only way to multiply to 1 is 1 times 1. And I know my signs have to be positive and negative. I'm going to put these arrows here because remember that when I multiply the terms associated with the arrow, I need to get my middle term, which is -3. So the nice thing about this problem, everybody, is there's only one way to multiply to 1. So that means that the numbers here have to be 1 and 1. But when I look at this, let's look at the top one, for instance, 2x and 2x. There is no way that a 2x and an x is going to give me -3x. So I can just erase that. That's not even close to being right. But on this bottom, if I do 4 times 1, that's 4x. If I do 1 times x, that's a single x. So if I want to get a -3, then I know this has to be -4, and this has to be positive. Once again, everybody, 1 times -1 is -1, and -4x plus x is -3. So now I have 2x, 4x plus 1, x minus 1. So remember that this is a third-degree polynomial, so at most we can get 3 answers. So when I'm looking at this, I have my 2x, so I'm going to do 2x equals 0. I'm going to do 4x plus 1 equals 0. And then I'm going to do x minus 1 equals 0. These are going to give me all my x-intercepts. So if I divide this by 2, x equals 0. So that's 0, 0. Subtract 1. Uh-oh. We're getting a fraction, which a lot of people dislike. And then this one right here. Sorry, I'm all over the place. You get 1, 0. So my x-intercepts are 0, 0, -1, 4, 0, and 1, 0. So I'm just going to go up here and kind of write them out, because you're going to need more room when we graph it. All right. So the one term that's kind of new in this unit is G in multiplicity. So multiplicity means how many times does a factor appear. So when we go down here, do we see that 2x happens once, 4x plus 1 happens once, x minus 1 equals once. So that means that the multiplicity is once or one time because it only happens once. And when something happens once, that's not interesting. We don't even care about it. We know that's going to be normal. It's only when a multiplicity is not 1 that we get some behavior that is unusual. So for this question, we're not going to have to worry about multiplicity. The multiplicity for all these factors are just 1. So now we're ready to graph. So now I'm going to erase everything because we already labeled everything on the top. So when I make my graph, I have the y-intercept of 0, 0. I have an x-intercept of 1, 0. I have a x-intercept of -1, 4, 0. And then, yeah, that's it. And then I notice it's odd and positive, so I'm going to start down, and I'm going to end up. So this means now I'm going to go through my points like usual. If there's nothing weird with the multiplicity, you just go through your points, and you are done. And that's it, everybody. So let's look at number 2. Number 2 is called factored form. How do you know that it's factored form? Because you see the parentheses and it's broken down. So I'm just going to do something real quick. I just want people to notice that x plus 1 is being squared. So I'm just going to write this as x plus 1 twice, just to emphasize what we're doing here. So remember, number 1, I told you the highest degree, which was 3, told you the degree of the polynomial. But when you're in factored form, everybody, you actually have to count how many x's you have to see what power it would be. Because if you actually distributed everything, you would end up with an x to the power of 4. If you don't trust me, you should try it. But I just want you to see that you got 1x, 2x, 3x, 4x. So that means that this is a 4th degree polynomial, and 4 is even. If we look in the front, there's no number, so I can technically put a 1 there for fun. And do we see that the 1 is positive? So we have an even and positive polynomial. So that means our end behavior is up, comma, up. And you need to refer to your chart to see that it's going to look something like that. So now we need to find a couple things. So let's find our y-intercept. So y-intercept, remember, x equals 0. Thus, you have to plug in 0 for everything. So you'll see something here. So 0 minus 2 is negative 2, times 0 minus 1 is negative 1, times 1 times 1, which is going to be a positive 2. So your y-intercept is 0, comma 2. All right. X-intercepts. This form is so nice, everybody, because everything is factored. So you just take all the factors and you set them equal to 0. So you get x equals 2, x equals 1, x equals negative 1, x equals negative 1. And so that means 2, comma 0, 1, comma 0, and negative 1, comma 0 twice. So this is a first example, everybody, of a multiplicity of 2. And that's because I'll highlight in green. Does everybody see that this happens twice? So when something happens twice, we say that's a multiplicity of 2. And you're going to see how that affects our graph. So, all right, we're going to do this one. I'm going to erase this graph to my left just so I can have some room to do this one. So I got my graph. And now my y-intercept, 0, 2, 2, 0. Let's spread the 2 a little bit out. 1, 0, and negative 1, 0. And remember, this is positive and even, so I'm going to start up and end up. So when something happens once, everybody, we go through the point. When something happens an even amount of times, we're going to bounce through the point. So you're going to see what I mean. We're going to bounce at negative 1. So you go do-do-do-do, and instead of going through, you bounce. 1 is regular, you go through it. 2 is regular, you go through it. And then look at this lovely graph. And that's how you graph polynomials. So what I'm going to do actually is I'm going to stop this video here. So if you just want to focus on graphing, you can look at these notes. Then I'm going to make a new video going over the factoring problems that are below, which are these 4.